Hey, it's Greg with Scholar Farms. Today we're in a pretty unique ecosystem in the state of California. These are vernal pools out here at Jepson Prairie. This is a UC reserve that protects these unique pools that come out in the springtime after the California rains. They fill up with water, and then as they dry out, then there's these beautiful annual plants that you see behind me that flower and compete for space in these pools and then set seed and then die fairly quickly. We're lucky enough to see them at peak growing season, and we're going to come out here with some drones that you see behind me. We got the EB, we got a couple other drones. We're going to map it in color and multispectral, and we're going to look at the patterns of species across this micro topography of these pools and really look at how drones might add a unique data layer to the research and some of the biology that goes on out here at the vernal pools. So I'm going to get up in the air and then we'll look at some data, and so let's go ahead and do that.
All right, let's look at some of the results, and we're going to start out with a Hangar 360. It's simple and intuitive. We can get a broad overview of the site. You're looking off into the distance, and let me just spin this pano around a little bit, and you can see some of the big areas of the pools. And note, here's a bigger pool, and you can see as it's drying out the ring of flowers around it. And then we can look at some of these other areas. This is not a standard pool here. It's more kind of an inverse of a pool with these little hilltops in the middle, but you can see all the flowers here as this pool dried out. It's pretty spectacular. Here I'll show you the cars for scale. So there's some cars off into the distance, so you can see it's just a huge area of flowers, and here's a pool that's still drying out, and the flowers are really tracking that dry down. Okay, so that's color. Let's look at some multispectral results. Here's just a quick view of the map that we made. Here's the 3D. I won't get into that in this particular video, but here's just the 3D point cloud that was generated. Let's look at the individual bands. We can see that here's the green band from the multispectral camera. You can see the flowers, but really if we look at the red band, so red light gets absorbed by plants, and you can see a lot of the grasses show up as a darker color. There's a clear dividing line there between one side and the other where they've excluded sheep and the grazing that have occurred. But you can really see the flowering here stands out pretty striking compared to the grasses, and you can really see the differences there. If we look at the near infrared and the red edge, what's striking here is actually the amount of variability out there and those topographical differences, so those really different microclimates that are popping out in near infrared and red edge. And those differences are super apparent here, actually. And we can look at the vegetation index as well, and we can pull those patterns out even more. So here's Ndvi. We're doing just a standard kind of red to green coloration. The green then would be all of the flowers there. You can see the red is higher Ndvi in this case, and that would be the grasses. But you can see the variability out there. It pulls out that visualization pretty well, and we can change that visualization. Here's the grazing too. That grazing line is really striking when we look at the vegetation index. If we change the colors to a thermal visualization, now this isn't a thermal camera, but it makes it look thermal. You can pull out then those yellow flowers appear as yellow. We can do the inverse where they're darker as well, and then the yellow would be the more productive grasses. So playing around with different colors can help you really tweak the visualization and look at the heterogeneity out in the field at this particular site. We can play around with a couple other different colors as well. We can go from the spectral, but we can also do kind of a consistent blue here that is really useful in terms of thinking about just a linear gradient of Ndvi and a heat map of productivity. But I really like how well this data set can use multispectral drone data and how much it brings out the pattern. It really illustrates
what drones can add to this type of field research. Just to geek out on botanical history here for just a bit, Jepson Prairie, where we have been mapping, is named after Jepson, a famous botanist who was around in the late 1800s, early 1900s, helped found the Sierra Club with John Muir, and was a really well-known botanist who went on to be a UC Berkeley professor. In fact, if you go to Berkeley today, the herbarium is named the Jepson Herbarium after him, and you can go in and read a little bit about his life and see some photos and things that are mementos. But really, the Jepson Manual is what he's so well known for. This is the plant Bible of California. If you've ever taken a botany class of California plants, you've used it. All right, so that's the vernal pools. I hope you enjoyed looking at some of those data. If you're interested in plant mapping with drones, you can go to scholarfarms.com and check out. We have a whole masterclass for vegetation mapping for agriculture, agronomy, ecology, forestry. We have lots of different case studies and example data sets. So if you're working in a professional field and want to learn to adopt and add drones to your data layers for vegetation mapping, check out scholarfarms.com. My name is Greg, and we'll talk to you soon.